So, some of you may know us as the creators of RGB, which is a smart contracting system for Bitcoin and Lightning, the Turing-complete smart contracts, which are made with a completely new approach, a new paradigm we call client-side validation. This paradigm has appeared from the early works of Peter Todd in 2016, so many years has been passed before we were able to introduce this into a life. And the core idea with the client side that unlike in blockchain, you don't keep data on chain, you don't keep data accessible by all the users. It is just a participants of the contract who know about the contract, who validate the contract, who hold the data, which ultimately results in a huge scalability and also privacy gains. So this new approach can be brought further. And today I would like to talk about the Prime, a system that can host a layer 1 for Bitcoin made with a client-side validation. Because basically the idea which we had with RGB is that we are using blockchain as a commitment layer. We are not storing any data in the blockchain. No smart contracts are there, unlike inscriptions, ordinals, and many other approaches. No user data are there, just a cryptographic commitment. And we're using a special primitive, which is called single-use seal, which allows us to reuse Bitcoin blockchain as a way of preventing double spending. And with that, the question we had, do we need a blockchain at all? And the answer that we found is that, in fact, we don't need blockchain as it is today. How the blockchain today works? Blockchain is literally a sequence of blocks, a chain of blocks, where the header of the block points to the previous block, commits to the hash of the previous block, and the block itself contains multiple transactions. And the header commits to these transactions through a Merkle tree. And the core property of blockchain is that everybody validates every transaction from everybody. And obviously this results that it scales really badly because the whole world needs to validate the transaction of the rest of the world each time. And it also a very poor privacy because to validate something you have to access the data, and basically the blockchain becomes a public ledger. Even the ledger is decentralized, the information is still centralized, which allows things like chain analysis and many, many other bad effects. So with Prime, the idea is that we change the concept. We still have this sequence of headers, but unlike blockchain, each party validates just its own part of transaction history. And the others in the world not just don't validate it, they don't know this history and they don't see what's going to happen there. And by doing that, we actually get a gain of both privacy and scalability. However, to achieve that, there is several tricks which are required, and basically that is what is the core idea behind the Prime, why it wasn't possible before, the client-side validation. There is a trick which prevents double spending here, because if we do that with existing blockchain, it wouldn't work, because if just an owner validates something, you can do a double spending, you can do a double commitment, nobody else validates that. And basically, if you receive some data from another user, you have no proof that he haven't sent some other party a different version of the history. There is no uniqueness of the history. So that's why we have this new primitive based on the Merkle trees. And the idea is that we replace UTXO with something called a single-use seal definition, which is random 256-bit number. It's not the private key, it's just a random number. And when the client assigns certain state to each number, so this state can be some number of bitcoins or tokens or any form of the smart contract state. And when he wants to transfer, do a transaction, he contacts the miner, so the Prime will require a certain interactivity protocol with the miners, And the miner builds a large Merkle tree, pretty much the same like it builds as a part of Bitcoin block. However, the place where this transaction are getting into this tree is a very well predefined. It's a singular one, and it's defined by the value of the seal divided by modulo on the width of the tree. So basically, there is always a proof that if a transaction has happened, it can happen only in a single place of the tree. And the way how it works is that when you do the transfer, you provide these proofs as well as the proofs of absence of the transaction in the previous blocks, because we basically disclose what was in this place where this transaction may happen, and if there's something else, then the transaction, it proves that the asset wasn't transacted before, and there is no double spending. With this approach, we get a huge scalability gain. Just to compare, the numbers are rough, like it's hard to say what is Bitcoin transaction on chain through output, but it's something in order of magnitude of 1,000 transactions per second, and it results in increase of the blockchain size, the data that you need to keep locally, about 200 gigabytes per year. On the other side, well, if used in full, on this other side with the prime, we have a logarithmical scalability, because we don't store this huge Merkle tree, like I shown on this slide. Oh, sorry. You don't store it locally, you don't download it locally, so it can grow to billions and billions of nodes. And you can achieve a throughput of up to 20 billion transactions per second, which 1,000 orders of magnitude more than the existing rate of credit card industry transactions. So this system potentially can scale to the level of something like, solar system scale civilization. And the price of that is that the user will need to keep just 6 gigabytes of data per year per single seal, and the system is structured in a way that most of the state under different contracts is reusing the same seal. And additionally to that, we have a serious gain that we don't have any public transaction graph. We are not having any concept of an address which we can reuse. Thus, no chain analysis is possible. The drawback that we have is certain interactivity with the miner. However, we have designed a schema where basically the miners are creating a big multi-peer lightning channel, and you use a special protocol that allows you to keep the user anonymous. There are other advantages which this approach provides. First of all, because it doesn't use elliptic curves, it's a post-quantum. Well, it can use elliptic curves on the layers on top, like inside the RGB, inside the smart contracts, but the layer 1 doesn't use elliptic curves, and it will also help to make the system to ossify faster, because without complexity on the layer 1, there is nothing actually to develop further. The system is quite simple, and it doesn't do any validation publicly, so you don't have public consensus changes on the validation algorithms, because each party validates its own smart contracts and free to upgrade in its own way. So basically it's an end for soft fork, hard fork debates. Another interesting thing that because it's stateless on the layer 1, all state and assets do exist on the RGB, which is layer 2 on top of this prime. So there will be no coin which is possible on the layer 1, which again, the idea is that this system will be an upgrade for Bitcoin blockchain, and Bitcoin will continue to exist as a main asset on this system. The prime provides also a native proof of work mining algorithm, because you basically, the miner, he creates the large Merkle root, and he needs to find a width of a Merkle root such that all seals submitted by the users regarding which are related to their transactions need to get into a dedicated certain place. So basically we need to find a number, when you divide the values of seals on this number, you will always get a distinct result. And this solution, so basically it's a native solution to construct the prime structure, and it requires a lot of standard mining computings, like with a SHA-256 hashes, but also it's not acceptable to the Bitcoin ASICs because there are different structure of this computation and there are other operations involved, like modular division. And it can well run on the modern CPUs and GPUs, on the simple machines, so it can be bootstrapped without ASICs before the ASICs are created. And to give you an idea of the workload on a modern machine, like Intel i9 processor with 32 cores, it takes 10 minutes to find the solution for the tree where it contains 200 seals. Of course, at the initial stages, if the prime will be implemented or when it will be implemented, the load would be much lower. So there will be a very gradual bootstrapping where the prime hash rate will be low and much lower than Bitcoin, with eventually getting to the level of Bitcoin hash power maybe many years later. And before that time, additionally to its own mining, the prime will be secured by pegging into Bitcoin proof-of-work algorithm on existing blockchain. After that, the pegging wouldn't be no more present, and the prime will run this proof-of-work algorithm without dependency on Bitcoin proof-of-work. So how the pegging will be done? It will be done with a merge mining, but with a different merge mining that it does today. So today you can merge mine by submitting a hash of a block to the miner, and he includes this hash into its Coinbase transaction. So this is how it works these days. There is a proposal to improve it, so-called blind merge mining, BIP 3.301, which requires soft fork. And this version works without soft fork. But miners need to be aware of the sidechains. They need to do the validation, and they need to upgrade their own software. So it creates quite a big threshold. We can reuse the same concept we are using in RGB with a single-use seal and create a new version of mining called single-use seal merge mining, where you don't need a miner to participate in the mining this other chain. Let's call it sidechain, but it's in fact not sidechain. This algorithm can be applied not only to the prime. Basically, it can work with any existing other sidechain, and it's quite surprising that nobody tried to do that. The idea is that you, at genesis of the chain, define some transaction output in Bitcoin blockchain, existing transaction output, which is anyone can spend. And then you create, a miner creates a transaction, so this can be any miner because the output can be spent by anyone, creates a new transaction in which it commits to the header of the block he found. And this transaction contains another anyone can spend output, and the process is continuing to run off. If somebody spends this transaction and tries to break this sequence with an invalid transaction, well, the single-use seal can be recreated, and basically the first transaction which recreates this single-use seal is the proper commitment for the next block. So this algorithm doesn't require any soft fork on Bitcoin. It doesn't require the interaction with existing Bitcoin miners who mine Bitcoin blocks. Miners do not need to run or validate anything new, unlike today merged mining. And main-chain miners and network do not even need to know about the sidechain or sidechain miners. Moreover, there is a permissionless participation for these new sidechain miners, and it's applicable to any idea of sidechain. So we're planning to use it with the prime, but basically other sidechain projects, they may use it instead of waiting for the soft fork BIP 301 to be activated. So the road to build such system as prime is quite straightforward. The only thing that is required is a technical implementation, and the most part of the business logic is already implemented as a part of RGB protocol. the layer 1 can be implemented in quite short terms, like about 1 year. No soft fork will be required to activate it. No merge mining and miner participation is required, as I just have demonstrated. And no regulator approval will be sought for. And the idea is that Bitcoin can eventually move to this system. Today it exists as a part of Bitcoin blockchain. With RGB, we are developing a way how Bitcoin can be lifted into RGB system on layer 2. And then eventually, when Bitcoin blockchain becomes less and less used, Bitcoin can continue to exist in Prime, in RGB on top of Bitcoin Prime. And the way how Bitcoin will be moved to RGB, it is trustless peg in and crypto-economically secure trustless peg out. Where basically I don't have much time to go into details on that, but we call this peg out a radiant. So it is made with a state channel. You may think about it as a very complex multi-peer lightning type state channel with a sequence of time locks, where initially when you go to peg out, you ask a federation to set up such a channel, which runs verifiers, which confirm, and these verifiers are open set, so they all provide a stake and they participate as from basically a community, so you can't predict who actually gets there. It uses a verified randomness. And if you are not agree with the decision by verifiers, when they try to cheat, you can penalize them with a stake. You can slash the stake, and you can use a special arbiters who comes from an open set and who need to reach a consensus. And if they reach consensus, you get the data back to Bitcoin blockchain. If it's not reached, the process starts again, and the arbiters are also slashed on their stake. And we have a formal model for that with a proof of strong Nash equilibrium that provides basically the guarantee that this system is cryptoeconomically secure, which is worse than being cryptographically secure, but still much better than what you can achieve with the Federation today. So these three things constitute the whole proposal that we have. Well, it's actually not proposal because it's not going to be a soft fork, so it's basically a proposal to develop a new thing, which is the Prime, the new client-side validated layer 1, scalable, private, and programmable, because RGB is a Turing-complete smart contracting, which works tightly connected with the Prime. The CL mining idea, where you can deploy and use side chains without miners being involved and without soft fork. And the Radiant, which is a crypto-economically secure peg in and peg out for Bitcoin from the main chain, and which is basically an alternative to BIP 300, where you don't need soft fork as well. So, without soft fork. How are we going to do that? Well, we are LNP-BP Association, the largest Swiss Bitcoin-only non-profit, which focuses on developing the layers on top of Bitcoin and for Bitcoin. And we run right now crowdfunding and seeking for parties who are interested in funding this development. It wouldn't be backed by some coin or ICO, anything like that, and it will be developed in the same way as RGB was developed. So if you are interested, please join the community channels which we have and become a member of the association supporting new layers for Bitcoin. Thank you.
Can you take a moment and for our live stream audience and also the people in the room, unpack the difference between crypto-economically secure and cryptographically secure?
Yes, for sure. Well, crypto-economic security is something that we have with a proof of work. You know that there is a Nash equilibrium, which is actually non-strong Nash equilibrium because there is a selfish mining, which is a strong Nash equilibrium. And Bitcoin is secured in these terms, crypto-economically. Bitcoin transaction finality is crypto-economically secure because you can have a reorg of the blocks. But still it works because people follow the egoistic self-interests and miners try to maximize their income and operate cooperatively. So the same security happens with this peg out which I am discussing. Cryptographic security, if you create a signature with your private key, and it means that it is just final by the mathematical means.
Okay, and what do you anticipate being the prime usages of Prime? What type of applications do we expect to find there, or replications of other applications?
Well, we hope that eventually Prime will replace Bitcoin blockchain, because it will allow Bitcoin to get rid of two main problems it has with the blockchain, which is scalability and privacy. So blockchain was necessary evil, but it is evil because it's not private and because it's non-scalable. There was no better way of doing Bitcoin those days. Today we have this way, and we believe that market will accept it, because for a long time it will exist in parallel, and it will be just market decision of market players to move their bitcoins to the other system, and it will be more scalable and more private. There will be a natural flow from one system to another until eventually Bitcoin blockchain will be stopped from being used.
So there's a point in time in which Bitcoin is bootstrapping the network, using the network effect and hoping to achieve a higher scaling, but at a certain point at which it is no longer necessary.
Yes, with the difference that we don't create new Bitcoin. Bitcoin as a store of value is the same, and it originates from Bitcoin blockchain. But because one day mining will not produce more Bitcoins, that day we wouldn't need a proof of work mining to mine Bitcoins. We will be just earning fees, and the miners will be interested to mine Prime chain, where they can get much more transactions and much more fees.
So you're perfectly content with waiting for your grandchildren to implement this?
Yes.
I love your thinking, Maxim. Do we have any more questions from the audience for Dr. Orlovsky? Please.
In your Prime chain, what happens if a miner refuses to give you a proof of inclusion to a user?
Yes, there is a way how you can appeal to that on-chain. You put this appeal into the header of the following blocks with some other miner, or you become miner yourself. And the miner has to publicly reveal the information about the inclusion, or then miner loses the fee, as well as you have a confirmation that the transaction which was included in certain block is not valid.
Another question? I mean, honestly, one of the reasons that I appreciate Maxim's work so much is he truly challenges me at the edges of my ability to understand this technology. So it's perfectly okay to feel dumb and ask a question out there, you guys, is what I'm trying to say, if you feel overloaded by it and there's not something you understand. No? Cool, thank you so much, Maxim, for joining us.